Hello boys and girls. In this video, we are going to look at a very special type of operators in C called unary operators. The reason that these are called unary operators is that unlike all other operators, they only require one variable to work on. They don't require two, which is the case for almost all the other operators. So for example, when you're doing arithmetic, you need two numbers in order to add them. With unary operators, you get to work with just one. So some of these will seem familiar. For example, typecasting is a type of operator that can apply on just one variable. We've seen that. Another one that is very easy to understand because we've seen it in math is the negative operator. So you can specify minus followed by a number or a variable, and this will be interpreted as the unary negative operator. It will be interpreted as saying this value is a negative number. Notice that minus is both an arithmetic and unary operator. I already made this point once before when we were talking about the percentage sign doubling up as the modulus operator in arithmetic and also the placeholder descriptor in format strings. This is called overloading, and you should not be confused by it. Another type of unary operator, which you will be using a whole lot of when we start doing loops, is the increment and decrement operator. Increment is plus plus and decrement is minus minus, and they basically just either increase the variable by one or decrease the variable by one. You can describe this or you can define this as a pre-increment operator or as a post-increment operator. The pre-increment version of this operator is syntactically written as plus plus some variable name, which means that you first increment the variable and then you use its new value. Instead, you can say variable plus plus, which means first use the variable's value in some operation and then increment it. And the same thing can be done for the pre and the post decrement. The variable's value will change for the rest of the program. So for example, when I write a program that looks like this, I can specify char A to be equals to capital A. I can specify float B to be equal to 3.31. And then I can print plus plus A and I can print B plus plus. Now what will happen when this particular statement is evaluated? So here I am using a pre-increment version of the increment operator for the character printing. And in this case, what that'll do is it will take A, the character variable A, which is storing the integer 65 under the hood, and it will add 1 to it to make it 66, which the ASCII table will map to B, and so it will print B. On the other hand, for printing the float variable B, we use the post-increment version of the operator. In this case, we will first print the value that we already have, which is 3.31, and then add 1 to it. So after the statement has executed, the value stored in the character box is B, and the value stored in the float box is 4.31. Then, when we run the next statement, we will see that we are using the pre-decrement version of the decrement operator, which means that we first decrement it and then we do the printing. So in this case, we will print A, and for the float, again, we use the post-decrement version, which means we first print the value and then we decrement. So we print 4.31 and then we decrement such that after this statement is executed, the value in char A is A and the value in float B is 3.31. Now these operators work with all data types with no exceptions, and so you should keep them in mind. Then we have unary operators, and unary operators of which that specifically are known as the size of operator. So the size of operator has two possible syntaxes. One is where you just say size of space var, where var is whichever variable you want to use. And the other syntactical way of writing it is size of, and then in brackets, the type. So, for example, if you have an integer box called x, you can write size of x with the space in between, and that will be the correct way of writing it. Instead, you could just say size of int, which would just return to you the size of the operand in bytes. So if, for example, if you say size of char, it will return 1. Size of float will, on most systems, return 4. On some systems, it may return 8. And this is very useful when you're trying to port programs across computers. 32-bit architecture systems use a different size of int. 64-bit systems use a different size of int. So if you are aware of this, then you will always have a size of check such that your program can be compatible across different computer architectures. As we already discussed, the typecast operator has already been seen, and the typecast operator essentially says instead of the variable that we have stored already, create a shadow copy of it in a box of the type that has been specified in the type operator as so. And so with this, you can get, for example, in this piece of code, I have defined a double. The double generally is of size 64 bits, so 64 bits is 8 bytes. But when you try and print the size of A, you will print 8. When you try to print the size of A typecast to a character, you will print 1 because that's the size of the typecast char version of A. And when you just try and print the char version of A, you will print basically just 67, which is C in the ASCII table. So you will print C. Feel free to experiment with such programs on Pruter. They will give you a better understanding of how these unary operators work, and it'll give you facility with their use also.